So I'd like you to find in your packet a sheet called Sampling Variability Questions. Once you've found it, go ahead and play the recording. Alright, so in this example we're going to look at a pretty interesting situation where we can actually see all the possibilities because the possibilities are few. Next time when you come in, we'll compare question 1 with question 2, which we're not going to do right now, a situation where we can't see all the possibilities. So, turns out we have a snake that lays 4 eggs. There's 1 male and 3 females. And they named them Martin, Alyssa, Tabitha, and Heather. Okay, so we're going to choose 2 of these baby snakes at random with replacement. Okay, so you get to take a snake out and then put it back in and take another snake. So your samples consist of 2 snakes. So it could be like, for example, Martin, Martin, right? You can take Martin, put him back in, and you might get Martin again. And then you might also have something like Martin, Alyssa, Martin, Tabitha. Go ahead and fill out the sample space. There should be 16 unique pairs here. And because it's with replacement, that means that just because Martin, Alyssa came up, you might again have Alyssa, Martin later on. I'd like to play that recording when you're ready. Okay, so hopefully you paused until everyone had this all laid out. Now, I'd like to find out the proportion of females. Okay, that's part B here. Find the proportion of females in all of the samples. Okay, so you should have here a list of the sample space. We're just going to go in and find the proportion of females. So in the first one with Martin, there's no females, right? So it's 0. In the next one, we only have 1 female. So the proportion would be half, right? So what I want you to do is go through and find out what the proportion is of females and write that over on the side. Play the recording when you and your partner have had a chance to fill all those out. Okay, so hopefully you've paused and figured out all those proportions. Okay, so depending on the order in which you listed out your pairs, you may have different order of these proportions, but we should all agree on the number of zeros. So we should have 1, 0 occur. So 1 dot on our dot plot. Go ahead and make a dot plot that represents all the different possibilities. So your 0.5, your 0, and your 1, and make a sampling distribution of the sample proportions based on what you have here. Play the recording when you're ready. Okay, so hopefully you paused and you have something like this. You've got 6 dots at half and 9 dots at 1. Okay, something like that. So we can see the sampling distribution. Now, here's the place where I really want you to learn this trick, this skill. We want to find a mean out of all these numbers. Now there's 16 numbers. You could certainly type them all in, divide by 16. It won't be too hard. Matter of fact, you'd probably do it in your head because you got a lot of halves and a lot of ones. It's pretty easy to add up. But I want to show you this cool technique. On your graphing calculator, there is a way to do a frequency list, which is useful here because there's so many repeats. So you're going to go into your stat and go into edit. And if there's data in L1 or L2, let's get it out of there. So let's go up to L1 and hit clear, enter. Now that's cleared. Do the same for L2 if there's any data in there. So what we want to do is list the possible outcomes. 0, 0.5, and 1. Those are the only possibilities. And then in L2, say how many times each of those outcomes occurred. So 0 happened once, 0.5 happened 6 times, 1 happens 9 times. Of course, that adds up to the 16, right? This is sort of like a little shortcut for having, as opposed to typing in all 16 data points. So this is useful when there's repetition. So you're going to press Stat, go to the right to Calc, do a 1-var stats because we're trying to find the mean. However, this is where you have to concentrate. Our list is in L1, but L2 has the frequency list. It tells us how many of each of those proportions there were. So to get to L2, L2 sits down here in blue above the 2. So you're going to hit second, 2, and it says L2. So cool. So calculate. And it gives us the 1-var stats, and the key statistic we wanted was the mean, which is 0.75. Cool. So what's the mean? It's 0.75. Get a different color if I can. And we should have been able to figure that out right. If I add half plus half plus half, that's a 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You divide 12 by 16, it's 0.75. What's the population proportion of the females? Well, there were 4 eggs, 3 were female, so that also is 0.75, right? Is the mean of the sampling distribution equal to the population proportion? Yeah, it is. And why is that? Well, this is a strange case. This is where we know all the possible sample of this size. Every pair we were able to list out. And this is pretty rare. There's no other samples that we haven't considered. Okay? So when you know all the possible samples of one size are utilized, the mean of the sampling distribution isn't just close to the population proportion, it is exactly the population proportion. It's a rare situation. We're not going to have time to work on this second question today. We'll pick that up next class. But you'll see here that we don't usually have access to every single sample of a particular size. Thanks for watching.